Good morning, good afternoon, good evening, everyone, and welcome to the world's most exciting classroom. My name is Joe Grabowski, and I'll be your host for today. We have a jam-packed episode 63 coming your way. Exciting times with the Oosterschelde. It has officially arrived in Australia a day early. Why were we a day early? Well, we hit a big squall, which gave us a big boost of wind. It was stormy, it was rough. But we made it into Sydney Harbour a day early. So we had a pretty awesome entrance into the harbour. I'm going to share my screen here really quickly, and I am going to show you where we are right now. So if you'll recall, we were sitting here for quite some time, 4 weeks in the Auckland area, in the North Island of New Zealand, undergoing maintenance. We crossed this huge expanse of the Pacific Ocean over several months. So the ship needed a little bit of care, a little bit of repair, resupply and such to be ready for the next few legs of the journey. It took us just under 2 weeks to cross the Tasman Sea here from New Zealand to Australia. And then here we are. If I zoom in, this is our live tracker. You can see that we are here. We are in Sydney Harbour, one of the most beautiful, epic harbours on the planet. And you'll notice some familiar landmarks here. There's the Opera House. There's the Sydney Harbour Bridge, and here we are right next door in Darling Harbour. So we have a spot there. We'll be there for the next few weeks. We have 2 groups of Darwin leaders coming. We have all kinds of exciting things happening in the field. It is going to be an awesome 2 weeks in Sydney before we head out south towards Hobart in Tasmania. So I have a little video clip here I want to share with you of our arrival in Sydney Harbour. It was a pretty big deal. We had a tall ship come out and meet us from the Maritime Museum. We had a fireboat shooting water cannons in the air, news helicopters. Let's take a look at a little clip of our arrival. Okay, there we go. So you can see we're in the harbor. We're making our way towards that pretty familiar site. The Harbour Bridge, the Opera House. If you look to the right, you can see those water jets from the fireboat. I think there'll be a better view in a second. A little cloudy, but no rain, so that's pretty good. You can't always get super lucky with the weather, but I think it was pretty exciting for the researchers, the crew, the passengers on board to enter the harbor in this way, one of the most iconic harbors on the planet. Okay, so what was really cool, I've got a little picture here that I want to bring up. We had a special ambassador come and join us as the ship was making its way into the harbor. So some of you may recognize this bird. This is a kookaburra. So not only, in the busy city like Sydney are they maybe a little bit rare, but to have one fly out and land on the mast of the ship as it was coming into the harbor, I think is a pretty exciting sign that we're going to have a pretty good time in Sydney. So this kookaburra came, it landed on the mast, and it pretty much sat on the mast of the ship almost until we got into Darling Harbour. So it really came in, I guess it was the pilot master maybe coming in to help guide the ship into Darling Harbour. So that was pretty darn cool. So before we get to our first guest joining us today, I want to share a little video clip from George Karinne. If you remember last week, George joined us from the ship. Him and Josh joined us. They had to be below deck because the wind was a little bit strong. We wouldn't have been able to hear them otherwise. But we caught up with George. He showed us some pretty cool weather phenomenon he'd been observing, and also the eDNA samples. He talked a little bit about the eDNA that they were collecting. So environmental DNA is pretty cool. We don't always see what's in an ecosystem. Humans are loud. They scare things away. Sometimes things are really small and hard to see. Sometimes they're just not there when we walk through an area to do a survey. But when we collect soil, when we collect water, we can look at the DNA left behind and see what organisms are living there and get a way better picture of the biodiversity of a given place. So we started that survey in New Zealand, and we're continued collecting eDNA all the way through July until our return to the UK. But let's take a look at this little clip George and I recorded together from Darling Harbour after the ship's arrival. Just bear with me. It's going to take a second to load, and here we go. George in here live with us right now in Darling Harbour. Hey, George, how are you?
I'm great, Joe. So good to see you, and it's so wonderful to be back in Sydney. It's been about 10 years since I've been here, and it is an absolutely gorgeous city. Uh, 12 days out at sea, and finally back on solid land, and I can still feel the ground moving a little bit, I gotta say. It's, it's quite the experience. We did arrive here in Sydney a day early because of some favorable winds that we had due to a storm that we weren't really expecting to spin up. This big squall came in a couple of nights ago. And as a storm chaser, it was fun for me, but also a little scary to be out there on the open seas and feeling the rage of Mother Nature's power. And we had lightning bolts, on either side of us, tremendous winds. I think we were in Beaufort, maybe 6 or 7 sea state. We were able to make up a lot of time because of the backing winds that we had. And we were able to get this sailboat up to over 10 knots, which is about 18 kilometers an hour, 18 and a half kilometers an hour. So we were just racing. And that's without any engine on, just the power of the wind. That was only on one sail. This ship is festooned with sails, and we only needed one to get up to that speed. That gives you an idea of the strength of the wind that we were encountering. And so we got into Sydney yesterday, and what a greeting we had. It was like they rolled out the red carpet for us. As we were coming into the harbor, there was the fire department there with their boat and shooting jets of water, these water cannons. It's kind of like the nautical version of fireworks announcing our arrival. There was another tall ship that was from the Nautical Museum here that came out that greeted us, and it was really nice. The two of us were sailing parallel to each other, and they even fired off a fake cannon shot at us, which I thought was kind of fun. And news helicopter overhead, drone flying, getting great video footage of us arriving, sailing right past the famous Opera House. Of course, the architecture of the Opera House is world known. And underneath the Sydney Harbour Bridge was really an epic moment as well. So right now we're docked here at Darling Harbour, right beside the Nautical Museum. And basically this is where my journey aboard the Oosterschelde comes to an end. It's been an amazing experience. It's had its ups and downs, quite literally, some really high highs, a few low lows, especially when I was feeling really seasick there for a couple of days. But got over that, and it's been just fantastic.
Yeah, it's a beautiful ship, but I imagine it felt a lot smaller when you were surrounded by that storm with the lightning and the wind and the rain.
Absolutely. When you look out on the horizon for day after day after day and see nothing but ocean, and then suddenly Mother Nature starts flexing her muscles, and you realize that if something goes wrong, you really have no one else to rely on other than yourselves and the crew and the ship itself. So you really feel very much like an astronaut out there floating in space, but in the middle of the ocean.
Yeah, and I know once you got within the range of Australian waters, you were able to start collecting some more eDNA. So it sounds like you've got more samples ready to go for our project, which is great.
Yeah, absolutely. Once we were able to cross into Australian territorial waters, then I was able to grab some water samples for the environmental DNA project that's going on. And I thought it would be fun to actually grab one from Sydney Harbour right here. So there's a fresh sample that I'll be processing in the next couple of minutes after I'm off the call with you. I have no idea what we're going to find in Sydney Harbour, but I'm sure it'll be quite interesting. One thing to note that really blew us all away yesterday was as we're coming into the harbor, a kookaburra bird, the famous Australian kookaburra, one of them landed on our mast. And these are typically not found in the city, let alone right in the middle of downtown Sydney. And it rode with us most of the way in through the harbor. It was almost as if the Australian wildlife had sent an ambassador to the ship to greet us. It was amazing.
That is a pretty good welcome. I think that bodes pretty well for our conservation projects with our Darwin leaders coming up. Oh man, I can't wait to see those pictures. That's really cool.
I've got so many photos to process and go through. It's I've got a mountain of things to do, and also I still want to see some of Sydney while I'm here, of course.
Yeah, absolutely. Well, the ship's in port. The eDNA project will be put aside for the moment until we get back underway again. What's the next few days hold for you, George? What are you going to try and get up to?
I'm going to be busy here in Sydney. I've got a lot of work to catch up on that I've been neglecting for the past couple of weeks. There's a media event coming up day after tomorrow, so I'll be involved with that. And then on the 18th, there's a really big event at Sydney Opera House where I'll be on stage with some of the other Darwin representatives and Darwin leaders, and it's going to be super, super epic. Really looking forward to that.
Yeah, that's going to be a good day. We're going to live stream our sail from Darling Harbour to the Opera House. I probably will run up to the Botanical Gardens. There's a big roost of flying foxes there, so I might do a little event with the flying foxes. So yeah, we definitely, and of course we'll try and live stream the event at the Opera House. So that'll be a great day to have classrooms, especially in the Sydney area, tuning in. And then of course we'll have the recording for our classes on the other side of the world. So that should be a lot of fun.
And I'm going to be seeing you.
That's right. A few days I'm flying out. And then I'm going to run all around New South Wales and Tasmania, getting out with as many projects as we can and hopefully broadcasting some really cool things to our classrooms.
Awesome. Leg 24 of the DARWIN200 expedition is now wrapped.
All right. Well, George, before we let you go, we always like to look around our surroundings. Do you mind turning the computer around a little bit and giving us the lay of the land?
Of course. So out that way is where we came in from. The harbor's entrance is down there. We got the beautiful skyline
district
of Sydney. There's the Maritime Museum over there. It's hard to see.
Yeah.
Yeah, over there. Another tall ship. So
yeah,
it's a beautiful, beautiful, beautiful harbor. Love it.
Perfect. Well, George, thank you so much. It was great to have you join us the last couple of weeks. Thank you for continuing the eDNA project. I'm so glad Mother Nature kicked up a little show for you before it wrapped up.
It's been wonderful. Thanks so much. And I'm signing off from Sydney.
All right. Thanks, George.
Cheers.
Okay, so there you go. That was a little catch up. Usually we like to do that live, but George is sleeping right now because he's on the other side of the world. So we have to pre-record if we're going to get a little bit of content for you guys here in North America, the UK, and other areas in these time zones. So yes, I am tomorrow flying to Sydney, and we are going to have a ton of really cool live events from the field. I have so many surprises coming up. It's going to be pretty crazy. You guys will have to catch them all the following day, the recordings, unless you want to stay up a little bit late. Maybe you could watch them at home and you can tune into some of them, but it is going to be a lot of fun. I'm really looking forward to it. So we're going to get right into it. We're going to meet a Darwin leader. We're going to have a little clip from a scientist in Perth who studies numbats and echidnas, who I talked to last night. So after we have her little lesson, we'll have our Kahoot quiz. And of course, we have our experiments and our curiosities still coming up. Luckily, we still have a lot of time left to go in our hour together. So you did hear George mention Darwin leaders. So we're going to have two groups of Darwin leaders in Sydney, but we've been having incredible Darwin leaders join us all the way along since April 2023. And now we're going to spend a little time live with Karinne Tennenbaum. So she was a Darwin leader in Puerto Williams in Chile. We had her visit us months ago to learn a little bit about the project she worked on. So we're going to follow up with her today, talk a little bit about her project, and play another one of the incredible pieces of media that she put together while she was in the field. So let's get Karinne in here right now. Hey, Karinne, how are you?
I'm doing very well. Thank you so much for having me.
Yeah, of course. It's great to have you. And correct me if I'm wrong, you're joining us from France today.
No, unfortunately.
No.
I'm in New Haven, Connecticut on the east coast of the United States.
Okay, that's still pretty cool. We've got me in Canada, you in the US, we have connections in Australia. So we are still jumping around the world today.
Indeed.
All right. Well, Karinne, I think the best place to start is because we'll have a lot of groups who haven't met you yet because it was last school year that we connected. Why don't you tell us a little bit about yourself?
Yeah, so it's so nice to see everyone. My name's Karinne, and I am a third-year undergraduate at Yale University studying ecology and evolutionary biology with hopes of being an ornithologist later on down the line. And I was a Darwin leader in January. I spent 10 days in Punta Arenas on a special expedition to Puerto Williams on Navarino Island. This is the southernmost town in the world at the tip of subantarctic Chile, and I had a fantastic time investigating threats to shorebirds.
All right. Well, I'm pretty jealous. That is an incredible spot on the planet. It's pretty south. It's pretty remote. Yeah, Karinne, that's you must have had just an incredible time being in that area. Probably no cell connectivity for a little bit of while, unplugged from the world for a bit.
Oh yeah, no, it was incredible. We were down in Patagonia. We took to get to Puerto Williams, you can either take a 2-hour flight or you can take a 32-hour ferry ride through the Beagle Channel, which was amazing. You got to see all the glaciers and the Cape Horn Biosphere Reserve. And there, you're up against the waves and just sort of with the other 50 or so people on board the ferry. So it was beautiful.
Okay. Well, I think now's a good time. We're going to play the third video you made in the series where we look a little bit at, what's next, what can be done next to help protect these shorebirds. And then as classrooms are watching, if you want to send some questions in via the private chat or via the YouTube chat, then we'll work some of those in afterwards. So let me cue this video up and let's take a look at it together. And then we will have a little Q&A action together. So here we go.
From Punta Arenas to the Agan Ferry to Puerto Williams, we set out on a quest to protect the shorebirds of Chile's Cape Horn Biosphere Reserve, the joining point of the Pacific, Mid-Continental, and Atlantic flyways. Last time, we visited the Cape Horn International Center, where we teamed up with Dr. Juan Rivero to survey areas along the northern shore of Navarino Island and evaluate 12 potential threats recognized in Chile's National Shorebird Conservation Action Plan, a subsection of the country's National Bird Conservation Strategy. Although the reserve seems free from anthropogenic impact, we found evidence of an array of threats: pollution, livestock, mining, and more. With our surveys complete, we determined the reach, average severity, and irreversibility for each threat we observed along the way. The most urgent threat, with 100% reach and severity, is climate change. This is evident by rising temperatures and greater precipitation in the region, the latter of which has recently been linked to lower avian species richness. The next two greatest threats are extensive livestock to the west and pollution to the east. This is not the first time that the biggest reserve in the Patagonia region has come under threat. In 2019, the local community came together to stop what would have been the first salmon farm in the Beagle Channel. The bulk of these cries of sin salmoneras came from the Agan, the local indigenous population. The victory protected more than just shorebirds. It saved the land itself. What can be done to counter these threats, especially climate change?
Lo más importante para combatirlo es complejo porque yo creo que es un problema mundial.
It's like a community that haven't been growing a lot, and there is an opportunity to reach the objective to have a sustainable life while protecting nature. So for that reason, Navarino Island is important because it has an opportunity to connect the people needs with conservation.
After my week in Puerto Williams, I believe the two main strategies are long-term research and monitoring and community engagement.
Creo que es muy importante el monitoreo constante, periódico, porque es la única forma de advertir a tiempo, en un momento clave, qué es lo que ocurre.
Fortunately, a long-term shorebird monitoring program is in the works, thanks to MODIS. The MODIS wildlife tracking system uses automated radio telemetry to track shorebirds on their long-distance journeys.
This program is a program that starts in Canada, starting this kind of devices that you put into the birds, and then you can follow in the migration. It's important because previously to this device, you put the GPS or whatever device and you need to recover the bird.
Right.
But this Motus system allows you to just put this device and then send a signal, and you have a net of antennas around North America, Central and South America. So that means that when the this bird, this shorebird that we put the device, start flying, and once it passes through an antenna, it detects. Important thing here is this is the southernmost antenna of the world. So we hope that this is the first one of many antennas that will allow later to know or to have more information which ones are the flyways or the stopovers of these migratory birds, because later for conservation you need to know or find out which ones are the places that we need to conserve, for example.
The MODIS program is a great start. However, maintaining a long-term shorebird monitoring program requires a new generation of young birders engaged in the conservation effort. Luckily, there is some hope on that horizon too.
I like to do ecotourism because it's a form of doing tourism, but not in mass tourism. It's most focused on the protection of the environment and the work with the local communities. If you want to do ecotourism, the first you have to do is to love nature and love all the wildlife.
Yo creo que es muy importante porque uno está aquí y ve que el lugar está muy prístino, que tiene muchos ecosistemas y ve los fiordos llenos de naturaleza. Entonces, si llegan, no sé, industrias como las salmoneras, ponen en peligro toda la diversidad de especies que hay y todos estos ecosistemas que son únicos.
Porque la conservación de las especies es algo súper importante, se preserva el ecosistema que ya existe y me gustan, son lindas de ver, es algo que se puede apreciar.
Yo creo que estamos como justo en el tiempo de hacer algo, porque si no ya yo creo que de ahí no hay vuelta atrás. Sería súper importante que más que, además de nosotros tomar conciencia, que también los sistemas educacionales como que cambiaran un poco para que también enseñar algo de conservación y eso.
Reaching out to youth and teaching them to use citizen science apps like eBird and Merlin Bird ID to identify the birds around them is an excellent way to cultivate an environmental ethic among the local community.
Hay científicos de la educación que trabajan con los profesores del colegio local para que los niños puedan recibir ese conocimiento, y nosotros creemos que lo que se enseña a los niños no puede ser contenidos globales, tienen que ser contenidos que tengan relación con su entorno.
The National Action Plan requires extensive collaboration between governmental, academic, and community organizations. This means active and frequent communication, crossing language barriers, and navigating difficult but necessary conversations.
It's great that Chilean and Argentinian researchers are working together in this project, sharing this beautiful place, and we are sharing similar problems and looking for similar response.
Through long-term shorebird research and monitoring, the education of a new generation of conservationists, and active collaboration and communication, we can protect Puerto Williams, Navarino Island, and the Cape Horn Biosphere Reserve, keeping it a magical haven for both us and the shorebirds.
All right, Karinne, another absolutely amazing video. We're going to take some questions from the chat here, but before we do, I want to remind, we've already got some coming in, so classrooms keep those questions coming in. But I noticed, you know, you go out into the field, you make these videos. Had you had any experience doing something like this before? Getting out in the field and then putting together, not only putting together a short documentary, but in such a short period of time?
No, I had never done anything like that. I had done some podcasting before, so I had some idea of structure and direction about where we wanted to take it, but we sort of just worked together as a team. It was like you said, it was a short time interval. I think that was probably our biggest challenge, was just in that short amount of time, making sure that we were able to talk to everyone. And we started filming right as soon as we got to the ferry. So a lot of those interviews were people that were on the boat, which was great. So even though we were just on the voyage itself, we talked to so many people, we got to hear about the project, and then we were able to do those surveys. And so we got it done thanks to our amazing photographers and my fellow Darwin leaders, and it worked out, which was great.
All right. I've got a question for you about the shorebirds you saw. What was your favorite species of shorebird?
My favorite species was actually that Magellanica oyster catcher. If you saw in the video, the black one with the orange bill. I've seen the American oyster catcher here in the US, but it was great to see that down there, and it was just adorable, and it was not that frequent, so that was really cool.
Okay. So part of the video talked about telemetry, so tracking the birds. And so the student's wondering, what was the longest distance traveled by one of the birds?
Oh, that's a very interesting question. I don't know the specific numbers for ones there, but I do know that 80% of the world's Hudsonian godwits overwinter in central Chile, in Chiloé, and they are flying all the way from Alaska to the southern tip of Chile, and that's about 14,000 kilometers. So very, very long distance migrations.
Yeah, there's that flyway that goes all the way along the coast, all the way from Alaska, all the way down the coast and into South America. So that's definitely a destination for a lot of them making their way down there. Yeah, very cool. We'll be connecting with a team of explorers at one stage, and they're going to bike the flyway, and they're going to talk to people along the way, collect film and research. So that should be pretty cool. Okay, so this one's about climate change. We know a lot about it here, but down in the communities where you were, is it something that they think about, something that they know a lot about?
Yes, I do think that it was super present in the people that I was talking to. They are all surrounded by the glaciers, and the people that are, for example, captaining the ferries, when you go and talk to them in the central control room, they tell you about how big the glaciers used to be, and how as you're sailing, you can see sort of where they've retreated. So it's something that everyone in the community is super hyper aware of and super conscious of when they're going about living their lives down there, especially in an area that is prone to a lot of human disturbance. There's a lot of cruise ships that are coming down there. So they talk about it very frankly with you when you're down there.
Yeah. So you were there. Yeah, obviously, you spent a week there. You met people in the community. You worked with the conservationists, including the young conservationists. So you saw the problem firsthand. When you leave the situation, and you get back home, how do you feel? Do you have hope that for the situation down there? Do you think there's a lot of good people on the ground there, so they're getting their hands on it?
Yes, absolutely. I was super inspired by the people I was able to work with while I was down there. Everyone at the Cape Horn International Center, which was the nonprofit we were collaborating with, which is an interdisciplinary project of research, conservation, and education. They're working with local schools, being able to talk to Vicente, Ryan, Antonia while we were on the boat. They're all university students. They're all super passionate about protecting the environment. And overall, getting a sense from the community that this is something important, seeing that action on the government scale with the passage of the Shorebird Conservation Action Plan. They're taking a lot of great steps. And I ran into River Gates, who is someone who's working at the National Audubon Society. So there's a lot of collaboration that's happening. And I was very, very hopeful when I left, and remain hopeful that they're able to keep doing great work down there.
All right. Well, Karinne, you obviously came home from your experience. You were selected as a Darwin leader because, you showed a passion for conservation. So we're curious as to, what's next for you? What's coming up? Are you studying right now? Do you have an expedition coming up? What are you up to?
That's a great question. So I am studying. I'm about halfway through my third year. Right now, I'm a member of the Young Climate Prize cohort, which is a nonprofit, which is a group that's run out of the nonprofit The World Around. And so I'm working on a project called Taking Flight, which aims to foster a new generation of climate leaders by increasing environmental ethics through birding. So the idea is to engage more members of the community, especially youth, in the climate conversation by exposing them to the world of birding and getting them excited about it. And so I'm working with this project. We have research and conservation efforts. We also have inclusivity efforts. And so I'm managing this as a hub out of New Haven, but hoping to branch out back to my home in Ann Arbor, Michigan. And so that's where all of my efforts are right now.
Awesome. Well, I am definitely looking forward to a little bird observation in Australia in a few days. Hopefully I'll snap some nice shorebird shots while I'm down there. Karinne, thank you so much. Thank you for your passion. Thank you for the work you did and the media you produced while you're in Port Williams. And yeah, best of luck in the future. And maybe we'll snag you one more time before the end of this epic journey as we sail around the world.
That would be amazing. Thank you so much for having me, Joe. It was great to see everyone, and best of luck with your time in Sydney.
All right. Thank you. Have a great weekend. Okay. Very cool. We love connecting with our Darwin leaders. There's such an amazing group from all over the world. There's a group right now in Sydney, Australia, running around on different projects with wallabies and platypus. And what else do we have? Sugar gliders, sharks and rays. Yeah, lots going on. So we're going to get to meet some of them as the weeks go on. They've had a chance to get home and finish their videos. Then we'll meet some of them and learn about the projects they were working on. Okay, we are going to play the results of an experiment we did a couple weeks ago. It was exploring the solar system. So if you recall, it was collecting some little materials to represent the sun and the planets, and then trying to figure out how far apart you should place them to represent our solar system. So we're going to play that little video. Then we're going to spend a little time with Christine Cooper. She's in Perth, Australia, before we have our Kahoot together. So let me get this results video queued up here from our experiment exploring the solar system from a couple weeks ago.
Welcome back, everyone. How did you get on thinking about the distances between the planets in our solar system? Well, in today's experiment, we're going to find out exactly how far the planets are relative to one another. I've put out this 100-meter long measuring tape that goes way down here. I'm going to start at this point here. If you remember, we used this orange balloon to represent the sun. So let's put the sun right here at the start of our measuring tape. The first planet, we used this little yellow pinhead to represent its scale relative to the balloon. This is Mercury. And Mercury would be 9 meters away from the sun at this scale. So let's walk 9 meters. 3, 4, 5, 6, 7, 8, 9. Here we go. So I'll put the little pinhead representing Mercury there so we can see it as we go further along the measuring tape. The next planet, Venus, would be about the size of this pea, and that's another 9 meters along the measuring tape, about 18 meters in distance from the sun. So let's walk out to about 18 meters along the measuring tape. Let's have a look, 18 here. So we'll put Venus right here, and I'll put another flag so we can see it as we go further. Earth would also be roughly about the same size of a pea. Remember, this scale is really approximate, but still. So that would be 25 meters from the sun. Let's have a look here. 23, 24, 25. So I'll put a flag there, and this P representing Earth right here. We used this tiny little red pinhead to represent the fourth planet, Mars, and that would be 38 meters from the sun. So we've got a bit of a distance to walk down further. So let's find 38 along the measuring tape. 38, 36, 37, 38. Here we go. So Mars would be about here. And I put this red flag here. The next planet, Jupiter, would be roughly about the size of this walnut in relative scale to the balloon at the start, representing the sun. And amazingly, that is 130 meters. So I think off the end of our measuring tape, but let's go and approximate it all the same. And remember, Jupiter is considered to be the gas giant of the solar system, but at this scale, it really doesn't feel that giant, does it? So look, here's the end of the measuring tape. This marks 100 meters from the start that the sun is. So we've got to go another 30 meters. So let's roughly count these out. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 9, 30. Okay, so very approximately, this is about 130 meters from the sun. So Jupiter would sit right there. The next planet, Saturn, if you remember, we used this hazelnut roughly to represent the size of Saturn. Saturn would be 239 meters, so 109 meters further from this point. So let's walk that out. I think I'm going to have to start approximating. What about 200 meters now? I think 239 meters is roughly around here at the start of this path. So let's put a flag here. And our little hazelnut representing Saturn would sit right there. The next planet, Uranus, would be roughly about the size of this pebble. And believe it or not, at this scale, Uranus would be over 480 meters. And I'm afraid I've actually run out of park now. It would be somewhere by those lights down there, I think. After Uranus, of course, we then have Neptune, which also would be roughly about the size of one of these pebbles. That would be an astonishing 749 meters away. So 3 times this distance, still further on. Probably somewhere way past those buildings in the distance. And last of all, Pluto, which at this scale would be the size of a 2-millimeter grain of sand, would be over 1 kilometer away. So right down there, probably somewhere near those cranes you can see in the distance. Just think for a moment about the mind-boggling scale of the universe, with Pluto as this 2-millimeter grain of sand over 1 kilometer away from the balloon representing the sun. It honestly is astonishing that the planets were discovered in the first place. And just to think of the technology that scientists have developed, not only to photograph, but to visit these tiny planets so far away in our solar system. It really is mind-blowing. So, how did you get on? Could you work out the distances between the planets in your solar system? How did they compare to the real distances that I've measured out here? Next time you watch a sci-fi movie and see shots of all of those planets bunched together like bowling balls, think to the real scale of the solar system. It is mind-blowing to consider how far all of these celestial bodies are from one another. Thank you very much for watching, and let's find out who won this week's prizes.
All right, very cool. I love that experiment. Who ran out of field, because Pluto, although we said it's no longer a planet, we still wanted to mark it just to show how far it was, would have been over 1 kilometer away from where he was standing. So those pictures we see where we can see the planets all lined up nicely, I guess they're good for a representation, but in reality, these are massive distances we're talking about. And you can see that was a huge field Stu was in. And once he got to Saturn, he couldn't put the planets in anymore because he ran out of field. They're that far apart when you do them to scale here on the Earth. So really cool. And thank you to the classrooms who participated and sent us in some pictures as they explored our solar system. We have one more guest speaker. I had a chat with her last night. Her name is Christine Cooper. She studies animal behavior at Curtin University in Perth, Australia. So on the other side of the country from where we are with the Oosterschelde in Sydney. And she particularly looks at birds and mammals. Right now, she's looking at numbats and echidnas, which are 2 really cool endemic species found in Australia. And she's looking at how climate change is impacting them. It's already really warm in Australia, but the warmer it gets, the harder it is for these animals to be out during the day and looking for food. So let's take a short look at her research. I think the video is about 7 or 8 minutes long, and then let's play a Kahoot quiz together based on what we learn from Christine. Have a live guest joining us. Really excited to have Christine Cooper joining us. She's joining us all the way from Western Australia. She's an environmental physiologist working at Curtin University in Perth. So she studies Australian birds and mammals and really looks at how they deal with changes in the environment. Particularly, I've hosted a few little events with her around the echidnas and the wombats and how they're adjusting to the heat changes that come along with climate change. So I'm going to bring Christine in with me right now. Hey, Christine, how are you?
Hello, I'm good, thank you.
Good, great. Well, it's great to have you in a live event. We've done a few little recordings for classrooms, and I'll probably share those with our classrooms after today's event as well. But it's nice to have you live and get you to share the work directly with the students.
Thank you for having me.
All right. Well, I think I'll let you take over for a little bit. I've got your presentation tucked backstage. After that, we'll get into some Q&A action.
Okay. So I'm really interested in how animals deal with energy and water and temperature in the wild. And one thing that animals that are active during the daytime have challenges with is keeping their body temperature in acceptable limits. And in Australia, most of our animals are nocturnal. They're only active at night and therefore they don't get as hot. But we have a couple of special species that are active during the daytime. And so I'm going to talk today a little bit about how we look at the thermal balance of echidnas and of numbats. So echidnas are really special. They're monotremes. They're really weird mammals. They lay eggs, they have spines, and they have really low body temperatures. And they've always thought to be really poor thermoregulators. So their lethal ambient temperature is meant to be only 35 degrees. In Australia, we get temperatures much, much hotter than that. And we thought that echidnas can only deal with behavior to deal with these high temperatures. So they're active in the daytime when it's cooler, in winter, and then in summertime when it gets hot, they just go away and hide during high temperatures. So they behaviorally avoid being exposed to these high temperatures. But we did some work out in an area called Dryandra Woodland where we have lots of echidnas, and we measured the temperature at which we found them active. We measured all sorts of different environmental measures of temperature and humidity, and we found that there are lots of times that the temperatures the echidnas were active at were higher than the temperatures which were supposed to kill them. And these are wild animals that are actually choosing to be out and about. They're all happy and healthy and certainly weren't in any risk of dying. So clearly they're much more tolerant of high temperatures than what people expect them to be. And therefore we wanted to know, how do they deal with this? They can't sweat like we do. They can't pant like dogs do. So how do they keep their temperature down? So we use some thermal imaging to do this. So we have a thermal camera, and it picks up the heat that is radiated from objects in the environment. So we filmed our echidnas as they were going about their business out in the field, and then we were able to look at different areas of the body and look at the different temperatures. And you'll note on this thermal image that where the animal is hot, it's losing lots of heat, it is a yellowish colour, and where it's cold is a bluish purpley colour. So we could get an estimate of the temperature of different parts of the echidna's body. And when we did this, we found the echidna has ways of losing heat. So one thing it can do is it can lose heat by convection. So it can lose heat to moving air. And it does this in between its spines, in the little gaps between its spines, and areas that don't have very much fur or spine coverage. So the insides of the legs, for example. And echidnas can also lose heat by conduction. So if you put your hand on a cold bench top, for example, that bench top will feel really cold to you. Well, echidnas do a similar thing. They will lay down on the ground and they will lose heat from their ventral surface onto the ground. And therefore, they're dissipating some of that heat to the cold ground surface. The other exciting thing that we found is that echidnas can use their nose tip as what we call a wet bulb or an evaporative window. So echidnas have a big pool of blood under the tip of their nose, and what they do is they blow bubbles to keep their nose moist. So you can just see that little bubble blowing in the echidna there behind the tree, and that means their nose stays wet. Now, this is really important for them to find their food because they can pick up the electrical signals of their prey, and their nose needs to be moist to do that. But it has the other advantage of being cold. So by having the water evaporate off the tip of their nose, it makes their nose tip really cold. You can see in these two pictures here that the nose is quite a dark purple colour. So it's really quite cold compared to the rest of the animal. And that's the heat that's being lost by the animal evaporating. So this explains how echidnas can deal with losing heat when they can't pant and they can't sweat. They are able to use evaporative windows and thermal windows to help dissipate the heat in their environment. Now, the other diurnal mammal that we have in Australia is the numbat. And it's the only marsupial that's truly diurnal, and it's endangered. So it's really important that we understand how it can function in its environment. So we did a similar thing with numbats as we did with echidnas. It was a little bit harder for numbats because they are endangered. There's not so many of them around, but we were able to film 50 numbats over the course of a year in all different weather conditions when they were out and about active at Dryandra. So we did this, and then we created a heat balance model. Now, this slide is horribly complicated, and you don't have to learn all of it, but it's just to show that creating a heat balance model is complicated. So we have to measure environmental conditions. We had to measure the surface temperature of different parts of the numbat. We had to calculate the area of those different parts. We then had to build a numbat model, and then we had to look at all of the ways that the numbat exchanges heat with the environment. So convection, conduction, radiation. We had to take into account the sun, cloud, scattered radiation, all sorts of different mechanisms of heat exchange. And when we did this, we were able to work out when numbats were gaining heat and when they were losing heat. So most of the time when they're in the shade, they lose heat, but there are times when even when they're in the shade, they're still gaining heat from their environment. And this means that they are not just relying on the heat that they produce from their metabolism, they're gaining environmental heat as well. Now, this is great for numbats to save energy. They eat termites, which are very poor in energy. So if they can gain heat from the sun, then they don't have to use as much of their own energy to stay warm. And their pelts are specially designed to help them gain heat. But it can be a bit problematic when they're living in hot conditions. So I did some work a long time ago that showed that numbats don't let their body temperature get above about 40 degrees. So we calculated how long it would take them to warm up to a body temperature of 40 degrees if they're out and about foraging. And this depends on the environmental temperature. But when it gets really hot, numbats will reach their maximum body temperature in only about 10 minutes, which suggests that when conditions are really hot, when it's really sunny, ambient temperature is high, they can only be out and about foraging for about 10 minutes. And clearly this is going to limit how much food they can find and ultimately limit where they might be able to live. So we need to use this information to decide where we might want to translocate numbats to if we're trying to establish new populations. We can't put them in places that get too hot. And we can also make some predictions about what might happen to them with global climate change as it gets warmer. So we've used this work to really think about how our special diurnal mammals that we have in Australia, our echidnas, our numbats, might be able to deal with changing climate and how we might manage those populations into the future.
I'm really super jealous because I love the work that you get to do. You get to be out in the field with the numbats, with the echidnas. It's pretty awesome. I know you mentioned monotremes, echidnas. We have our platypus, which is the other monotreme, the only egg-laying mammals, which is pretty cool. And the work you're doing is so important because the temperatures are changing, things are getting much warmer, and it's having an impact on those animals. And 10 minutes foraging, that is not a lot of time to look for food.
No, so it could become quite problematic for them. And we have to start to think about what aspects of their environment might be important. So we've always thought the open, clear areas are important for them to get their termites, but maybe shade is really important to them. And we have to think about where we might want to translocate them. So hot desert areas might not be the best places to put them. Maybe towards the south where it's a bit cooler might be better translocation areas.
Well, Christine, it's so good to have you for a live event. We're loving our events for your side of the world, Australia, New Zealand, and any other classrooms who feel like joining us. And it's so great to have some content of some of those amazing endemic species that you have there in Australia. They're so special.
Yeah, we're pretty lucky with our wildlife down here.
All right. Well, Christine, enjoy the rest of your week. Thank you so much for being with us. And we'll let you continue with your day.
Thank you so much for having me.
All right. Thanks, Christine.
See you later.
All right. 2 examples of endemic species that can be found in Australia, the echidna and the numbat. The echidnas are doing okay. The numbats are endangered. And like Christine mentioned, if the temperatures are hot enough right now that some days they can only search for food for 10 minutes, that is not a great thing for their populations, and it's going to inform their conservation decisions. If they release some captive bred ones into the wild, they have to make sure they're doing it in the right spot where they're going to have the best chance to survive. So while she was presenting, I had a little Kahoot quiz pulled together. So I'm going to share my screen. We're going to play this Kahoot together. And remember, there is a prize for the winning classroom, a $50 Amazon gift card. So it's going to load up right now. There we go. Oh, nope, that's the wrong one. There we go. So it's going to come up on your screen. You need to go to kahoot.it, kahoot.it if you want to play along. And then it's going to ask you for a PIN number. 59572. So multiple ways you can join the class. That way. If not, maybe your teacher can pop this up at the front of the classroom. You can shout out your answers to him or her. If you're joining from home, you can scan that QR code and it will bring you into the event. If you can't get on with technology, well, play along anyways and see how you do. I can see we've got a couple classes in there already. So kahoot.it and your PIN number is 859572. I'll give it another few seconds, see if we get another couple classrooms in here with us. And then we'll play our Kahoot and wrap up with our curiosity of the week. Next week, the next time you see me, there'll be a bunch of events throughout the week. I will be in Sydney and we'll be getting out into the field with some of the projects that we're collaborating with. So that's going to be a lot of fun. And yeah, instead of just one event, there'll be a whole bunch of events over the course of the week. And I'll send a schedule out in a newsletter as well. So you'll know when those are coming. I'm going to give it about 10 more seconds. And then I think that we will go live with this Kahoot. We're going to have our Curiosity of the Week. And I think we might just end today's event within the hour mark, which would be pretty good because we usually go over a little bit. Okay, let's get playing a little bit of Kahoot. So first question coming your way in our Kahoot about Christine's work in Western Australia. So this is a multi-select. Pick the 2 mammals that lay eggs. So there's 2 mammals in the world that lay eggs. Is it the echidna, the kangaroo, the sugar gliders, and the platypus? You have to pick 2 of these. There's a clue decoding for you there as well up on the screen. So you need to pick 2. The best 2 answers there. All right. So it is the echidna. It is the platypus. We call them monotremes. They're a primitive mammal. They're the only mammals that don't have live birth. They lay eggs, which is pretty incredible. Okay, Arctic cat holding down the lead. Let's get to our next question. This is a true or false one. Echidnas blow bubbles to help them cool down. Is that true or false that echidnas blow bubbles to help them cool down? We got 2 more seconds on the clock. All right. That is absolutely true. So their noses are wet, so it's cooler. They lose heat through their noses, and then blowing those bubbles as well helps keep the nose nice and wet, and that helps it stay cool, and that helps them regulate their temperature a little bit. Okay, rapid iguana has snuck into the lead. Let's go to our next question. This is true or false coming your way. Numbats are herbivores. They only eat plants. Is that true or is that false? The numbats are herbivores. They only eat plants. You've got about 10 more seconds to get an answer locked in. Are they herbivores only eating plants? All right. Ooh, we fooled everybody on that one. That is false. They are not herbivores. If you remember, Christine talked about termites. They look for termite mounds. They have really long, sticky tongues that they can use to slurp up some of those termites. So numbats are definitely not herbivores. Okay, rapid iguana holding on. We have one more question. This is a multiple choice. When it's really hot, numbats can only look for food for how long? Is it 5 minutes, 10 minutes, 30 minutes, or up to an hour? So when it's really hot, how long can they be out there looking for food? 5 minutes, 10 minutes, 30 minutes, or an hour. There we go. It is 10 minutes before they reach that temperature. I think Christine said it was if their body temperature gets up around 40 degrees, they just can't be out anymore. They have to find shelter. So on some really hot days, with the way the climate's changing in Western Australia, that can be reached within 10 minutes. And that is not a lot of time to find all the food they need for the day. Let's take a look at our podium. In third place, we've got the dazzled elephant. Holding down that second spot, we've got the soaring griffin. And in first place, the Arctic cat. All right. I'm going to stop that screen share. We're going to stop that music. If you are the classroom with the Arctic cat, I need you to send me a message to classroom@darwin200.com. I'm going to put that up here in a little banner so you can see it. So classroom@darwin200.com. If you are the classroom, or maybe you're a student, a homeschool student, you can send a message to classroom@darwin200.com, and we'll make sure we get that Amazon gift card coming to your classroom. Okay, here we are. We are at the end of today's event. We have to look at our curiosity of the week. So last week's curiosity, I happen to have examples of it right here. We know it was something in the rock. We know it was a mineral. So here is what we saw from the Darwin studio. I also have an example here of what it looks like in another form coming out of the ground. Let's take a look at our results video from the studio and see what our answer is.
Welcome back, everyone. Last week, I asked you to try and guess the identity of this strange cubic object. Could you work out what it is? Well, this is a very strange object with its cubic shape and flat, square sides, and this bizarre but beautiful metallic, almost golden colour. The colour is a bit of a clue. It's known as iron pyrite. It's a type of iron sulfide, sometimes known as fool's gold. Fool's gold is widely found around the world. Here are some other pieces. You can see that same cubic structure in the tiny crystals in these pieces. It's quite widely distributed and found right the way around the world. Miners used to find pieces of fool's gold like these, and many were tricked into thinking they found actual gold. But when they brought it to the surface, they found that it was nowhere near as heavy as real gold and nowhere near as valuable. Did you correctly identify this crystal as iron pyrite or fool's gold? Or were you tricked just like the miners?
All right, so there we go. It comes in these different forms. This one is my favorite. I mean, coming out of the rock, it's this golden, perfectly formed cube. It really is quite amazing, pyrite. But like Stu said, it's just not really worth a whole lot, although that could be changing because they're finding more use for pyrite in technology. So who knows, maybe those miners' luck will change and pyrite could be worth a little bit more in the future. There was a classroom, Naircourt Primary School in South Australia, and they were the winners of the Curiosity of the Week this week. Let's look at our new curiosity before we say goodbye and sign off for today.
Back, everyone. For this week's curiosity, your task is to try and research and find out how sea urchins are related to starfish, also known as sea stars. These two groups of marine organisms superficially look very, very different. Of course, sea urchins have a hard calcium carbonate exoskeleton from which spines protrude, whereas starfish look very different indeed. But believe it or not, these two groups of organisms are related. Send in your answers to classroom@darwin200.com for a chance to win a £50 Amazon gift voucher prize. Join me next week to find out the answer and who won the prize. Thank you for watching.
There we go. That is our curiosity. We know what it is. One is a sea star, one is a sea urchin. It's your job to figure out over the course of the week how they are related. So you want to send that answer into classroom@darwin200.com. And maybe like our lucky class in South Australia, we'll be sending a $50 Amazon gift voucher your way. So there we go. We are at the end of our 63rd episode of the world's most exciting classroom. We're only 1 minute over time, which is pretty awesome. Next week, we'll be doing a whole series of live events from Sydney. The time zones won't be super friendly for us here in North America, South America, the UK, Europe. However, the recordings will be available the following day. And you never know. Maybe if you're joining from home, you might want to stay up a little bit late to tune into some of those events live. We'll share that whole schedule shortly in one of our Darwin 200 newsletters, so you'll know what is coming your way. Last thing we have to do today is a shout out to our sponsors, partners, supporters, without whom we wouldn't be in Sydney, Australia right now. We wouldn't have young Darwin leaders in the field learning conservation tips and tricks and tools. We wouldn't have our eDNA experiment going on, and we definitely wouldn't have the world's most exciting classroom. So that's how we'll wrap up today. A little thank you to our sponsors. I hope everyone has a great weekend. I will be, flying for approximately 30 hours to make my way to Sydney, but then I will see you live from Australia for a whole series of events. Have a great rest of the week, and we'll see you soon.